Hi and welcome back to Free Science Lessons. In the last video we started looking at standard enthalpy change of reaction. In this video I'm going to give you a question to try yourself. This equation shows you the reaction between zinc and silver nitrate solution. Because zinc is more reactive than silver, it can displace the silver from silver nitrate, and this reaction is exothermic. 6.54 grams of zinc was added to 200 centimeters cubed of silver nitrate solution, with a concentration of 1 mole per decimeter cubed. Correcting for cooling, the temperature increased by 42 degrees Celsius. Calculate the standard enthalpy change of reaction. Now, to answer this, you need to know that in this reaction the silver nitrate is the excess reagent. So pause the video now and try this yourself. Okay, first we need to calculate the heat energy released by the reaction. To do that, we use the equation Q equals mc delta T. We use 200 centimeters cubed of solution. Because this is an aqueous solution, we can assume that the density of this solution is close to the density of water, in other words 1 gram per centimeter cubed. This means that the mass of our solution is 200 grams. Because it's an aqueous solution, we can also use the specific heat capacity of water, which is 4.18 joules per gram per Kelvin. The temperature increase was 42 degrees Celsius, and remember that for this equation we treat degrees Celsius as equivalent to Kelvin. Putting these numbers into the equation gives us a value of 35,112 joules. Dividing by 1000 gives us 35.112 kilojoules. Now, at the start of the question, we were told that the silver nitrate is in excess and the zinc is the limiting reagent. So to work out the standard enthalpy change of reaction, we need to divide the heat energy by the number of moles of zinc. We have 6.54 grams of zinc, and the molar mass of zinc is 65.4 grams per mole. Dividing 6.54 by 65.4 tells us that we had 0.1 moles of zinc in our reaction. Okay, so now we can divide the heat energy by the number of moles. Dividing 35.112 kilojoules by 0.1 moles gives us a value of 351.12 kilojoules per mole for the standard enthalpy change of reaction. And because it's exothermic, we need to give this number a negative sign. Okay, I'm going to give you one more question to illustrate a really important point. If we go back to the definition of standard enthalpy change of reaction, we can see that this is the enthalpy change when a reaction takes place in the molar quantities shown by the balanced chemical equation. So take a look at this question. 5.4 grams of aluminium was reacted with unlimited chlorine under standard conditions. 70.6 kilojoules of heat energy was released. Calculate the standard enthalpy change of reaction. Now, to answer this question, you need to know that aluminium has a molar mass of 27.0 grams per mole. So I'd like you to pause the video now and try this yourself. Okay, we know that 70.6 kilojoules of heat energy is released when 5.4 grams of aluminium reacted. The molar mass of aluminium is 27.0 grams per mole. Dividing 5.4 by 27.0 tells us that we've got 0.2 moles of aluminium. Remember that standard enthalpy change of reaction has to be based on the balanced chemical equation. From the balanced chemical equation, we can see that 2 moles of aluminium take part in the reaction. However, in this experiment, we only had 0.2 moles of aluminium, and this released 70.6 kilojoules of heat energy. So to calculate the standard enthalpy change of reaction, we need to multiply minus 70.6 kilojoules by 10. This gives us a final answer of minus 706 kilojoules per mole for the standard enthalpy change of reaction. And remember that the minus sign tells us that this reaction is exothermic. Okay, now the units of standard enthalpy change of reaction are kilojoules per mole, and you might be wondering what that means. What does per mole refer to? Well, the per mole actually refers to the whole balanced chemical equation. So what that means is that if 1 mole of this entire balanced chemical equation takes place, in other words 2 moles of aluminium react with 3 moles of chlorine to make 2 moles of aluminium chloride, then 706 kilojoules of heat energy is released. Okay, so hopefully now you can calculate standard enthalpy change of reaction.